Get started. All right, awesome. So we are looking at solving systems by graphing. All right, let's talk about what an actual system of equation is in the first place. This is our big vocab for today. Again, if you want to paraphrase a little bit in your notes, that's okay, as long as you get the general idea. So what is a system of equations? It is two or more linear equations, and EQNS is the abbreviation for equations with the same variables. So essentially, up to this point, we've been graphing one equation. Now we're going to graph multiple equations. We're going to have two of them. And the way that this is going to look on a graph, basically, we're going to have two lines. Now, when we say solving, there are two ways that we're going to look at solving those systems this unit. The first is what we're doing today, and this is solving the system by graphing. And to decide what the solution of that is, you're going to look where those two lines cross or intersect. Now, when we get to solving them algebraically, there are a couple ways to do that. We're not quite there yet. But when we do get there, we're looking for those two values that make both the equations true. Right now, I just threw a lot at you guys. So when you are ready, can you throw in the chat your favorite food? When you're ready to move on to the next slide, throw your favorite food in the chat. Mac and cheese, yum. I think we're thinking of like deer. That's a new one. Okay. Nachos, a staple. Evelyn is in agreement. All right, I'm going to give you, if you haven't finished yet, I'm going to give you 15 seconds, then we have to move on just for the sake of time. Remember, if you do ever miss something, the Jamboard is posted in the week at a glance, so you can go back and see what you missed. All right, here we go. There are going to be three types of solutions that you're going to see in this unit. The first one is our most common. This is what you're going to see most of the time. Essentially, we graph those two lines, we see where they cross. And when you give a solution, when it looks like this, you're going to give us an ordered pair as your solution, kind of like how we did the ordered pair in our Do Now today. But there are two less common scenarios that you might run into. These are kind of our special cases. They don't happen as often, but they do happen sometimes, so we have to know what to do with them. The parallel lines. So if you have two lines that don't intersect, let's think about this. Our solution to a system is where the two lines cross. If the lines never cross, we can't have a solution. So if you encounter two parallel lines, you're going to write no solution, or you can write DNE for does not exist. And I'm going to be honest, in calculus, we use DNE all the time. So you guys are using some calculus notation. Make sure you are getting these down. Remember, easy extra credit for doing your notes with us. All right, then the very last solution type that you might see is when you have the same exact line. So when you have two of the same line, you graph them over top of each other. Those are crossing each other at every point. All of the points are the same. So that would mean we have infinite solutions, or you could write our little infinity sign. If you are struggling to write the infinity sign, you can turn your paper, write an 8, and then turn it back. So those are the three types of solutions we might run into. I'm going to move on here in about 15 seconds. If you have questions, don't forget you can throw them in the chat or use that question feature that Google Meet just added. All right, let's get to it. We're going to jump right into our first. Oh, no, we're not. Before we get there, I want everybody to kind of review something that we did a lot last unit, but we haven't done maybe in a little while. I want to convert this to slope-intercept form. Anaya, what am I doing with this equation if I'm trying to get it in slope-intercept form? What is my goal here? Yes, thank you. We are solving for y. So everybody take about 30 seconds here, solve for y, and then I'm going to call on one of you. All right, let's hear from Brianna. Can you turn on your mic and tell me how I would solve for y here?
You would subtract the 20x.
Good. Then what do I get?
You get negative 20x plus 45. Well, 5y equals negative 20x equals 45 plus 45.
There you go. Now what?
And then you would divide negative 5 from the y.
Yep, and we're going to divide every single term. So what did you get as your final answer here?
Y equals 4x plus minus 9.
Good catch. Awesome. So this is a skill that we're going to use quite frequently today. If something isn't given to you in y equals mx plus b, you might have to rearrange a little bit to get it to look like that. All right. So here we go. We're going to jump right into our first example. Now, as we're graphing today, it's super important. You'll notice I have it highlighted down here, that it's super important that we're precise today. So my suggestion to you, if you have a ruler, that's awesome. If not, just get something with a straight edge. I'm just going to use like this notepad and use the side of this to be my straight edge today. The more precise you are, the better in this situation. Okay, so our goal is going to be to graph both of these lines. So I'm going to look at both of my equations, and I'm going to pick out the slopes and the y-intercepts so we can graph them. So in this, sorry, I should be writing this in black, actually. Oh my goodness, Miss Carr. And y equals negative 2x plus 1. Perfect. Okay. So now we get our slopes and our y-intercept. So in this first case, our y-intercept would be negative 8. And our slope here, there is no number there. What do you think our slope is, guys? Throw it in the chat if you know. What's our slope in that first equation? Thank you, Caitlin. Our slope is 1. Good. In this second equation, we have a slope of negative 2, and we can write negative 2 over 1. Remember, we want them to be fractions. And our y-intercept is 1. So I'm going to graph both these lines, and if you have 2 different colors, that would be awesome. This first one I'm going to make blue. The second one I'm going to make green. And we're going to look and see where these blue and green lines cross. So this first line, I'm going to put a dot at negative 8. And I apologize. I'm trying my best to make everything accurate today, but it's not perfect in the virtual setting. And now we're going to go, because our slope is 1, we're going to go up 1 over 1. And honestly, the more dots you can put, the better. in this case. It's going to be more exact if you put more dots here. So I draw all my dots, and then I'm going to connect my lines. I have my notepad that I'm using as my straight edge. And your line should look something like that. Right? Remember, if you have a question, you can raise your hand. Our green line, I'm going to do the same thing. I'm going to start at 1. We begin with B. And then I'm going to go down 2 and over 1. Did I mess up? Oh, I started it. What did I mess up there? Anybody catch it? I started at -1 instead of +1. Silly Miss Carr. All right, and we can see once we start graphing here, our lines are going to cross at a certain point, and that point is our solution. So what I'm going to do is I'm going to circle my solution, and then we have to come up with an ordered pair. So think back to what we did for our do now. We need to come up with an ordered pair for our solution. What do we think it could be, guys? You're a quiet bunch today. Damari, what do you think my ordered pair is for the point I just circled? Remember, guys, it's important to participate.
Is it like, I'm trying to count. Okay. Is it 3? So the green circle, right?
Yeah, the one I circled in red. That's the point what we're trying to name. Yep.
So I know it's over 3.
Mm-hmm. Then what's our Y value there?
Is it 5?
Close. You went, it's on the, it's like down.
Negative
so
5.
It's -5. There you go. So our solution is going to look like that ordered pair. What questions do we have so far, guys? Or better yet, can I get a general feel? Can you give me good, bad, Tell me how you're feeling here. You can just throw it in the chat. Soraya is feeling good. Evelyn's feeling great. Awesome. All right. All right. I'm going to take the silence from the rest of you as a good thing. Make sure we're paying attention. Again, if I'm going fast, remember these notes are linked in the Jamboard in the week at a glance. So we're actually going to skip to example 2 here. Skip all the way to example 2. This is number 3 if you have printed out the notes. And this time it looks a little bit different. As I look at my 2 equations up at the top there, I do not have those in y = mx plus b. So the first thing we're going to have to do is solve both of these equations to get y by themselves. And this is that skill that we practiced at the start of our notes. So we're going to write out both of our equations. I'm going to use the space on the side to solve. And our goal is going to be to get y by itself. All right, so Soraya, I'm picking on you. Can you walk me through this first one? How would I get y by itself? What would I do?
Hold on. Give me a second. Sorry, I got my little sister here watching her. So
that is okay.
You minus 3x on both sides. Well, -3x on both sides.
Yeah, so we're going to minus a -3x. If we're minusing negative, what does that mean we're doing?
Sorry.
Yep. So we're going to add 3x. Good job. Now what?
I really don't know. You add the 3x on the other side to the 8, and I don't know what to do after that, honestly.
Hold on, pause. You were doing really, really well. Are 3x and 8 like terms though, Soraya?
No. Oh, so you write them next to each other. Yeah.
Yeah, there you go. So we're just going to put them right next to each other. And we actually, that's it. That's all we have to do. Normally we would have to divide by something, but because y was all by itself, we're good there. We only had to do that one step. Thank you. You can turn off your mic.
Okay.
Miss Hart, it's a positive 3x.
Ha! Thank you. I was just testing you guys. Okay, so then moving on to example 2. Here we go. We're going to do the same thing that Soraya just taught us. We're going to move that x to the other side. And we're going to be left with y equals, again, those are not like terms. So we're going to have x minus 2. And now we have two equations that are in slope-intercept form. But our next thing is that we need to pick out the slope and the y-intercept to try and graph these. So Finn, can you turn on your mic and tell me what the slope and the y-intercept is of that first graph? Hello? Oh.
So this graph right here, the one that's on the screen?
I'm looking at the equation y equals 3x plus 8. Yeah, what is the slope
y
and y?
3x plus 8.
Say that one more time, I'm so sorry.
Y equals 3x plus 8. The slope is 3.
Good. And do you remember how we'd make that into a fraction?
Yeah, 3 over 1.
Good. And our y-intercept then?
8.
Thank you, Finn. Perfect. Okay, so then our next graph underneath, you can turn off your mic. I'm done torturing you. So then for our slope and our y-intercept, our slope here is hidden, but it's an invisible 1, and our y-intercept would be -2. Okay, so again, I'm going to graph both of these, and I'm going to use 2 different colors here. If you have those 2 different colors at home, that's awesome. If not, just try and mark things as well as you can. All right, so my top line is blue, so I'm going to start at 8. And then I'm going to go up 3 and over 1. And I went a little bit off the graph, but that's okay. And remember, we can really rewrite this. This can also be as -3 over -1, because 2 negatives make a positive. So I can also go down 3 and back 1. A little hard to count on here. And the more dots, the better. Okay, so I have a bunch of dots there. I'm going to connect them with my straight edge. Remember, whatever you have at home that is straight. Oh, no. It moved the whole picture. Oh, gosh. Okay. The pressure's on. All right. And then my green line. Here we go. Same thing. I'm going to start at -2. And I'm going to go up 1 over 1. And again, the more lines, the better. I could even go back 1 and down 1 if I want. And boom, we have our second line. So now I have my 2 lines, and we're looking for where they cross. And it's kind of like X marks the spot. You're looking for the middle of that X here. So I'm going to circle the point where they cross. And then we need to name that point. So if you know the name of that point, will you throw that in the chat, please? Our ordered pair for that point. Ooh, Evelyn, you're close. You forgot something. Oh, Soraya, you're close too. There we go. They're both negative. We went back and down. So our ordered pair here would be -5, -7. All right. One more time. Can I get a good, bad, Tell me how you're feeling in the chat, please. Okay, a couple of you are feeling good. That's awesome. If you have a question too, now would be a great time to ask it in the chat as well. All right, majority of us are feeling good. So I'm going to move on to our very last example, and I'm actually going to skip, if you're on the Jamboard, I'm going to skip all the way to frame 10. I want to show you guys a special example. Okay, so again, we're doing the same process, graphing these two lines. Is the first line in slope-intercept form? Is this one in slope-intercept form for us? Yes, it is. However, the second one is not. We have the x and the y on the same side. So we're going to have to solve for y again. And to do that, I'm going to move the x over. Then I'm left with negative y equals negative x plus 2. Who knows what my last step should be here to get y by itself? We do have to get rid of, there is an invisible 1. I love that you guys are recognizing that. But we're not subtracting 1 here. Yeah, Brianna has got it in our chat. She says we need to divide by negative 1. Negative 1 and y are right next to each other, meaning they're being multiplied. So here we go. I'm going to divide by negative 1, and I'll get y equals 1x minus 2. So for this equation, our slope is 1, and our y-intercept is negative 2. For the for that first equation, we already had that we didn't need to rewrite. Our slope is 1, and our y-intercept is 5. Before we even start graphing, do you guys notice anything about these two equations? Caitlin, can you turn on your mic and explain how you knew that?
Well, I meant to spell parallel, but I can't really spell that well, but they have the same slope, so that's how I knew.
Yes, they have the same slope. So let's just double check that Caitlin is correct here. I'm going to make this line blue and this line green. And we're going to sketch both of these. So I'm going to start with my blue line at 5. And our slope is 1, so we're going to go up 1 over 1. And remember, the more dots, the better, the more exact it's going to be. And with my straight edge, I'm going to the best of my ability, draw a straight line. And then I'm going to repeat this process with our second line. So now I'm down here graphing this equation. We put a dot at negative 2. And again, we're going to go up 1 over 1. And the more dots, the better. So now I have my two lines, and this does confirm what Caitlin said she thought was going to happen. These two lines are parallel. They do not intersect. So, Shemaya, do you know what that kind of answer would be if these lines do not cross?
Like what you mean? Like give me options.
Sure. We had 3 options at the start of class that we talked about. It was one of these 3. So what type of answer?
It'll be no solution.
Perfect. Thank you, Shemaya. You can turn off your mic. So for this last example that we just did, our answer would be no solution. Or if you want to be fancy, use our calculus notation, you can write DNE for does not exist. What questions do we have right now? You're okay, Gabrielle.